Hello friends, and welcome to the next lecture of Big Data Tutorials. We have already covered 2 lectures so far, and this is the third lecture. And in this lecture we are going to dive a little deeper into Hadoop, and we will understand how Hadoop works internally. So let's get started. So like I said, we will basically talk about some of the basics of distributed computing, and we will try to relate those basics to Hadoop. We will also look at the differences between the traditional database processing systems and Hadoop, and how Hadoop is better or worse than those systems. And we will also have a look at the core components of Hadoop. So first of all, let me just rewind the definition of Hadoop. We covered this definition in the previous lectures as well. So think of it as just a refresher. So as per the definition which is available on Wikipedia, it says that Hadoop is basically a collection of open source software utilities, basically libraries, that facilitate using a network of many computers to solve problems which require massive amount of data and computation. So if you have a problem space where you have a lot of data and you require a lot of computation, and you want to execute that process or that job into a parallel manner, then Hadoop is something which can be utilized for that purpose. There is another simpler definition for you to remember. If you have to use the definition for academias, then you can use this definition, which says Hadoop is a framework which allows distributed or parallel processing of large data sets across a cluster of commodity nodes. When I say commodity nodes, it basically means that these are pretty vanilla nodes. They do not have really high configurations in terms of CPU or GPUs or RAMs. They are pretty basic machines, computing machines, and they have a pretty simple programming model as well. So that's about the definition of Hadoop. And in fact, when you try to install Hadoop, I mean, it's much more than just an exe. I mean, initially, if I thought that it was just an exe, it's not. It's much more than that. And we will look at that, how Hadoop is installed and how Hadoop looks in practice as well in the coming lectures. So let's move forward. As I said, that we will also touch upon the basics of distributed computing. So when we talk about distributed computing, there are some components which come up in the stack of distributed computing. So it can be a data center, which is basically a building which hosts a lot of clusters of computers, and a cluster can be imagined as a collection of connected computers. Or maybe let's try to understand this with the help of a diagram, and we can see how cluster, data center, node, application software, and operating system fit into the stack of distributed computing. So let me just switch to my note, and if I try to show you with a visual diagram. So let's say this is a data center, and then you have bunch of computers. We call these computers as nodes. I mean, single computer will basically be a node, so let me just call it as node. And then each of all these nodes are basically connected to each other via network, because that's how distributed computing works. So you have a bunch of computers which are connected to each other, and they all can work parallelly. And in addition to that, now once you have a node, on a particular node you will have an operating system. Basically, it can be Linux, it can be Windows, it can be Mac, it can be any other flavors of Linux like RHEL, etc. And then on the OS you have your application software. So if I go back to the presentation, so we talked about the data center, which is basically this whole big box, basically a building. So I can just write it as data center. And then we said that a data center will have clusters of computers. So this is basically a logical cluster, and each cluster will have machines basically called as nodes. So these all are nodes, and then on each node we will have an operating system. So these nodes will be running some sort of operating system, and then an operating system you will have the application software of Hadoop and your code as well, obviously. So this is how the basic distributed programming model stack looks like in practice. So hope this explanation was helpful, and if not, please share your feedback in the comment section, and we'll try to help you. Okay, so let's move on. Let's briefly just talk about the history of Hadoop as well. So basically it all started somewhere around 2000s and 2002 when Doug Cutting started the work on building this framework called Hadoop. Then in 2003, Google File System, or GFS, which is published by Google, this laid the foundation of HDFS. Now what is HDFS is something which we will talk about in the coming slides, but this is basically, you can think of it as a distributed storage system in a very brief definition. Then moving on, around 2004, Google also introduced the concept of MapReduce, which basically changed the whole scene of distributed computing, and MapReduce solution was basically tailor-built for distributed computing. We will again talk about MapReduce in detail in the coming lectures, but for now we can understand that this is a programming model which supports parallel and distributed computing. Then around 2008, Yahoo also released Hadoop as an open source project in collaboration with Doug Cutting, and then in 2011, Apache Software Foundation releases the first version of Hadoop, which was 1.0, and it became open source. Completely redistributable code as well. So this was about the brief crash course of history of Hadoop. This is something which is something which you are not going to be quizzed about in your interviews or in your exams, but this is just something to have a context about Hadoop. So let's talk a bit more about Hadoop's characteristics. So the first characteristic and the biggest characteristic of Hadoop is that it is scalable. It can scale to any limits, and when I say any, basically it means any number of machines. Now when we talk about scalability comes in two different aspects. It may be a vertical scalability, or it can also be a horizontal scalability. Now what do we mean by these two scalabilities? Let's understand that again with the help of a diagram. So when we talk about vertical scaling, let's imagine that we have a computer here, and it has some RAM capacity, some CPU power, it may have some memory as well, the hard disk, right? So it has certain capacity, and this is, you have bunch of clients here, and all of those clients are basically hitting multiple requests to your server. Then if the requests are too many, then there would be a time when your server, if this is your server, then your server just can't cope up with the requests, and at that time all the RAM and the CPU and the memory is just exhausted. So you need more space, you need more power to serve more requests. So in that case, in case of vertical scaling, you will just increase the RAM or the CPU or the disk capacity. If the RAM was earlier 4 gigs, you can just make it to 8 gigs, or if there were earlier let's say 4 CPUs available, you increase those to 16 CPUs. So depending upon what kind of requirement is there, you can scale the machine vertically. This is what we mean by vertical scaling, right? So this is how vertical scaling works. Now when we talk about horizontal scaling, if you take the same scenario that you have multiple clients who are hitting your server with multiple requests coming in, and your server, again, if we imagine the same server which we had in the previous example, so if it has some CPU, it has some RAM, it has some memory, right? And now the machine can't cope up with the traffic. So instead of vertically scaling the machine, you can horizontally scale it, which means that you spin up more machines with the same capacity as the original machine, and you connect all of these machines via a network, and then maybe you can put a proxy server here, and all the clients are basically throwing the request to the proxy server, and then the proxy server is routing those requests to either the first machine, the second machine, the third machine, the fourth machine, or the nth machine. It depends upon which machine is available to take up the requests. So you see the difference. In case of vertical scaling, you're not increasing the number of machines, but you're increasing the power of the existing machine. But in case of horizontal scaling, you are not increasing the power of the same machine. Instead, you are spinning up more similar machines to increase the overall power of the system. That is what we mean by horizontal scaling, and that is the difference between vertical scaling and horizontal scaling. So let's go back to the slides. The second thing is about reliability. So Hadoop has a property that it stores minimum 3 copies of the data across its nodes, across its servers, and under the hood it has HDFS, which is supporting Hadoop basically. And HDFS, like I said, is basically a distributed storage system, and HDFS will create replicas of the file blocks depending upon the replication factor and stores them on different machines. Now there are a bunch of terms thrown here. File blocks are nothing but the blocks where the data is written, and the replication factor is basically a number which will govern to how many machines you are going to replicate the data, because that is how Hadoop is going to build the resiliency, right? So if you have, let's say if you have a simple text file, I'm taking a very naive example here. If you have a simple text file which you want to store in the Hadoop cluster, then what HDFS will do, that HDFS will store that text file at multiple places based on the replication factor you define. If you define a replication factor of 3, then that text file will be replicated to 3 nodes in the Hadoop cluster. If the replication factor is 5, then the text file will be replicated to 5 nodes in the Hadoop cluster. So that's what we mean by replication factor here, and that's how Hadoop basically builds the resiliency. So now you can see, even if one of the machine goes down, the Hadoop cluster can still access your text file from the other nodes which are still alive. The third thing is being economical, because we are using ordinary or commodity computers or nodes or servers. All of these terms mean the same thing. So because we are using very ordinary computers with very simple CPU and RAM configurations, they are not very high-end configuration machines, so it also becomes quite economical. In fact, you can set up a very tiny Hadoop cluster using your laptop as well, or even desktop can also be used as a server. There is no requirement to purchase high-powered machines, because if you can have small tiny machines and a lot of those tiny machines, then accumulatively all of them together will produce more power and more parallel distributing capabilities for Hadoop. Okay, that was about characteristics of Hadoop. Moving on, just some points around the differences between traditional database systems versus Hadoop. So when we talk about the traditional database system, all of the data is stored in a single server. So if I go back to this diagram, so this can be thought of as a traditional database system. Though nowadays traditional database systems also support a cluster of servers, so you can actually have more machines, but they are still not same as Hadoop, because you cannot scale to thousands and thousands of servers in a traditional database system. This works well if you have data in gigabytes or terabytes, but if the data goes even beyond these magnitudes, then the traditional database servers just cannot scale vertically or even horizontally in that case. And even if you try to make that work, the performance will be heavily degraded, because there would be so much configuration and sync up required to manage all of those servers that it would become really a big pain for the database administrators. And in fact, the whole relational database systems do not have the capabilities to access the data which is sitting in the magnitudes of exabytes or petabytes. The traditional relational database system just cannot survive that load. So in Hadoop, the data is present in all the nodes in the cluster. Like we said, that we have a replication factor concept where the data is replicated to multiple nodes. So all of the data is sort of distributed. Hadoop works pretty well even if your data is in thousands of terabytes or petabytes or exabytes and even beyond. And Hadoop also scales vertically as well as horizontally, so it's your choice, though we don't recommend scaling vertically because the power of Hadoop really lies with distributed and parallel computing. So you can spin up more and more nodes, but obviously nothing stops you from scaling vertically as well. So the performance is virtually unlimited. It depends upon how many machines you can add, or how many machines your cloud provider or your data center provider can provide you to add into a Hadoop cluster. More the servers you have, higher will be the performance. So talking about the core components of Hadoop, there are basically three components of Hadoop which basically build the whole skeleton of Hadoop, which is HDFS, Yarn, and MapReduce. So HDFS is something which we have already talked about in bits and pieces in this tutorial so far. So it's a Hadoop. The full form of HDFS is Hadoop Distributed File System, and it acts as a distributed underlying storage engine for the complete Hadoop cluster. HDFS will be installed on every node which you spin up or add into a Hadoop cluster. Talking about Yarn, the full form of Yarn is yet another resource negotiator. It's kind of funny, but the whole point is actually what is meant by the definition, that it is just a resource manager, nothing much, nothing less, nothing more. You can't expect it to do fantastic and funny things. It will just be acting as a resource manager, and it will also be acting as a job scheduling tool, which is again the responsibility of a resource manager. The third component is MapReduce. So MapReduce is basically a technique or a programming model which you can use to implement distributed computing. Now MapReduce technically is an algorithm which you use to build your programs on, and this algorithm contains two important parts, which are map and reduce, and we will talk about what do we do in map and what we do in reduce in the coming lectures. But for now we can understand that the very basic skeleton of Hadoop stands on three components, which is HDFS, Yarn, and MapReduce. And that brings me to the end of this lecture. So in today's lecture we talked about the basics of distributed computing. We understood what is Hadoop. We talked about the characteristics of Hadoop. We also understood what is vertical scaling and horizontal scaling, and how Hadoop basically benefits from the horizontal scaling concept. We also try to look at a contrast between the traditional database systems and the Hadoop system, and how they stack against each other. And we also talked about the core components of Hadoop, which is HDFS, Yarn, and MapReduce. So that's it for today's lecture, and we'll see you in the next lecture. Thank you for watching.